Okay, back to Bergson and the holographic theory of mind. This is part 38, Hoffman's interface. It is Donald Hoffman, perception theorist, the user interface model of reality and consciousness. And there'll be an attempt to reconcile Hoffman insofar as it can be done to Bergson. But the hard problem, his solution, hardly. Natural selection, he's a bit overboard. Kind of got a math theory of everything with his conception of mass explanatory power kind of running amok. And as this is an idealist theory, it's time to look at idealism's fundamental problem. So a little prelude. We'll call it mathematics derangement syndrome. Already in 1896, Bergson was trying to combat this. He saw mathematics continually being confused for the real, as if mathematics possessed an ontological status. Bergson warned mathematics could at best be a descriptor of physical reality. It can form laws that describe aspects of this reality. For example, invariance laws, F equal ma, force equal mass times acceleration, force a function of mass and acceleration, or the spring force, a function of its distance that it's pulled back, and a constant, or as I like to discuss, the invariance structure with the various invariants described or defined across coffee stirring. So invariance laws, but reality, the humble coffee stirring, the coffee cup, all its physicality, physical events, the physical universe infinitely overflows mathematics. But this warning has gone unheeded. So Donald Hoffman is a perception theorist and researcher at UC Irvine. He's done a couple books, for example, this visual intelligence book, How We Create What We See, and Observer Mechanics, a Formal Theory of Perception, with a few other people, 2014. And he has a new book coming on his theory of consciousness, The Case Against Reality, coming in August 2019, subtitled Why Evolution Hid the Truth from Our Eyes. He's been in a ton of YouTubes discussing his theory. So many so that it seems safe that he's covered the essentials of his thought before one can read the book. What we'll see is a motivation of the hard problem that seems very close to Bergson initially, but he is far from the understanding of a Bergson. And in his proposed solution, he veers off in a direction that shows this. In a 2018 interview, Hoff described his intellectual journey. He started off in quantitative psych. He worked with David Marr, who was a famous, well-known AI vision theorist, for his PhD thesis. He had great interest in the question, are people machines? How do machines think? Can I see what the differences are? He got into vision because, to quote, it's a way to solve really concrete problems. To quote him again, if you jump into consciousness too early and don't have the tools to address it, you are not really prepared. And I second that 1,000 times. His key mindset, it's an evolutionary mindset, is as such. Initially, like most cognitive neurosciences, I assumed that our senses evolved and we were shaped by natural selection and shaped to show us true properties of the world that were important for our survival. I did not think evolution shaped us to see all of the truth, but that it shaped us to see those aspects of objective reality that are critical to our species to survive. He became involved in mathematical models, how the visual system recovers or reconstructs the true 3D shapes, colors, motions, and other properties of physical objects. For example, how one recovers cubeness from a rotating cube, the fact that it's a cube. And in visual intelligence, I notice he accepts Ullmann's rigidity theorem. That is, one can have 3 points on the cube. That's all one needs as the cube rotates to recover the rigid structure of the rotating cube. Unfortunately, this has all been overthrown. The strobe cube I like to talk about, out of phase, out of its out of phase with its symmetry period, becomes a wobbly, non-rigid, plastic-like object. Or the ellipse up there rotating too fast. Its velocity vectors tend to go astray, shall we say, and it becomes a wobbly, non-rigid ellipse. But Hoff pays little attention to flows, the time itself. So he quotes, so the idea is that there's a real space-time out there that exists, whether or not anybody perceives it. And there are real physical objects out there with real properties, position, shapes, mass, and so forth, independent of whether anybody is looking at them. And the goal of our visual system and our sensory systems, more generally, is to recover true properties of this existing physical world. His take on the standard view, quote, the brain is a very sophisticated computer that is taking in information from the senses and computing an understanding of the world that is important for our survival. It's recovering those true properties of the world that our species need to survive. So that's his view of the normal cognitive scientist. But the first step to his breakout relative to the standard view is such, quote, I realize that it might not be the case that evolution would favor sensory systems that report to truth. We have evolutionary graph theory, and we can actually prove theorems now about what the effect of natural selection will be. I decided I needed to step back and look at consciousness from an evolutionary point of view. What do selection pressures do to our sensory systems? Shape us to see the truth or not? He started running computer simulations, hundreds of thousands of artificial worlds. Quote again, we put resources in the world, each of these artificial worlds, and we could change what are called fitness payoffs that you would get for obtaining these resources. We put creatures in those worlds and had them forage, and some of the creatures, called truth creatures, we let them have sensory systems that could see all of the truths in the world, all of them, and other creatures we had such that they could see none of the truths. All they could read is fitness payoffs. These creatures were allowed to compete. And what we saw is that creatures that saw the truth always went extinct when they competed with creatures of equal complexity that saw none of the truths but were just tuned to the fitness payoffs. This was a bit of a jolt. Hoff worked with a mathematician, J. Prakash, and proved a theorem of natural selection. As the senses get increasingly complicated, that an organism sees the truth will be more fit than an organism tuned only to fitness and sees none of the truth. The probability is precisely zero. In other words, an organism tuned to fitness has far greater probability, in fact 100% probability of surviving, as opposed to an organism that just sees the truth. Now, I've not read Hoff's studies, papers on this, but what wonders is on the nature of resources. He seems to be talking, and as we'll see later, it seems more and more like this, that he's talking something like this. I put a piece of bread in my world and let the creatures compete for it, and those that see that the bread is edible, and of course thereby can feed themselves, do well. But if I see the bread as a pile of atoms, its truth, well, there's not much worth in eating that, is there? I mean, it's not particularly edible. It's a pile of atoms. One can begin to see that these creatures that are tuned to fitness or tuned to the truth, as Hoff describes it, are not going to do too well, depending on how you set up the computer simulation. But I think that's what's going on. Hoff noted, think of it as a big video game. We're running around trying to get points to move to the next level. As in evolutionary theory, get an apple, you get certain fitness payoffs. Fall off a cliff, you have negative fitness consequences. In the game, focus on grabbing points to get to the next level, else you're not going to get anywhere. In evolution, focus on getting fitness payoffs, else you are going to be less fit and apparently go extinct. Quote, so to the extent that your perceptual systems are tuning you to payoffs, this is good in terms of fitness. They will not be telling you anything about truth, because the fitness payoffs do not preserve the true structure of the world. Now, pause here for a second, slight comment. Notice the structure over there in simply stirring coffee, an invariance structure, velocity flow fields, adiabatic ratios, inertial tensors, etc. Plenty of structure, mathematical structure. So what does he mean by the true structure of the world? We'll get back to this. So now we come to the metaphor, the desktop metaphor, the heart of his interface. To quote, if you're using a paint program, Adobe Illustrator or something like that, and you have a paintbrush icon that you're using to paint some color into a region of your artwork, does that paintbrush icon on your screen mean that inside your computer there's a paintbrush that looks just like that paintbrush on your screen? Well, of course not. If the paintbrush icon is in the middle of the screen, does that mean that it's in the middle of your computer? Well, of course not. Anybody who thought that misunderstands the point of the interface. To quote, the interface is not there to show you the reality of the computer, the diodes, the resistors, the voltages, the magnetic fields. See, this is what he means by the truth. It's there, in fact, to hide the truth of the computer, all that complexity, and to just give you simple eye candy, tools that let you accomplish certain tasks, that let you control the computer, even though you are completely ignorant of what's really going on inside the computer. So for objects. And so that's what evolution has done for us. It has given us sensory systems that are like a desktop user interface. Space and time as you perceive them are your desktop. And physical objects like apples and trees, forks and spoons, these are just icons in your desktop. If we are shaped by natural selection, he argues, the probability is zero that the predicates of space-time, matter, physical objects, shapes, are the right language to describe objective reality. Again, the probability is zero that you could even phrase a correct description of reality using the language of space-time and matter and physical objects. So evolution shaped us with a language to keep us alive, but that language just does not have the right tools to describe objective reality. Asked about drugs, he noted, certain chemicals, we can hallucinate all sorts of realities. This shows we can create realities which we have never seen before. So that ties in to the idea that we are the authors. We are constructing the visual and sensory world that we perceive. He notes brain area V4 and the occipital lobe, the visual area V4, the arrow pointing there. If you take a strong magnet and set it near V4, on the left side of the brain, on inhibit mode, people will have lost all color experience. Just shades of gray are seen in the right visual field. Left is controlling right and vice versa. Pull the magnet away and the color comes seeping back. Dozens of things like this. We talk about neural correlates of consciousness, NCCs, but correlation does not imply causation. Now, this is kind of an inherent contradiction. I mean, he's saying at the top we can create realities, but then he implies that we're not causing them. This will reap its rewards later on, as we'll see. Felix is already thinking about it. So Hoff asks if in fact brain activity is causing our conscious experience. We have found many NCCs, neural correlates, but there is no precise mathematical theory that explains how brain activity causes conscious experience. So, beginning of the mathematics emphasis. There is not a single scientific theory that can say this pattern of brain activity must be the taste of chocolate. It could not be the smell of garlic or the sound of a trumpet. And here's the scientific reason why. Now, I would say, have they ever tried to discern this structure, the invariant structure, neurowise? Look at the neural pattern corresponding to this large set of mathematical laws that would describe coffee stirring. And of course, one would expect that this set of mathematical laws would vary differently and could be detected differently, and that would be specific to cake batter stirring as opposed to coffee stirring. And of course, obviously, quite different from the invariance laws describing swinging a baseball bat. Now, wouldn't this be a worthy activity to find this scientific theory that can say, yes, with this kind of structure across the brain, we would have coffee stirring as opposed to cake batter stirring? But no. And then another note. This list, taste of chocolate, smell of garlic, the sound of a trumpet, it comes straight from the standard qualia list in the hard problem list of qualia. In other words, as we've seen already and discussed, it's a problem coming straight from the classic metaphysic, and we'll revisit that again. So the hard problem is, Hoff describes it. This is the so-called hard problem of consciousness. It's hard because in some sense, from a physicalist point of view, it's a mystery. No one has a good idea about how brain activity, without magic, a magic wand up there, could create conscious experience. And of course you can't in the classic metaphysic of completely homogeneous space and time. We'll get to that. So why this problem, the hard problem? To quote, the very language of space, time, and physical objects is simply the wrong language to describe objective reality. These are all icons that we use to interface with a reality that is not physical objects. If that's the case, then it's no surprise that we use the language of physical objects such as neurons. If we use it, we cannot describe how consciousness arises. We are using simply the wrong language. It's just false that space exists when it's not perceived. It's false that physical objects like neurons exist when they are not perceived. These are simply icons that we create when we need them, and then we garbage collect them when we don't need them. They're data structures that describe fitness payoffs and actions that we can take to achieve these payoffs. End of story. There are no insights into objective reality. So if we take a thoroughgoing evolutionary point of view, an apple is just a data structure that the eye creates to represent certain fitness payoffs that are available to me in certain ways that I can obtain those fitness payoffs, certain actions. So if I look and see an apple, I'm creating that data structure. And if I look away, I'm garbage collecting it. So stunning to my colleagues, neurons do not exist when they are not perceived. Therefore, neurons do not have any causal powers. Neurons cause none of our behaviors, none of our conscious experiences, none of our sensory experiences. And so from that point of view, it's no surprise that the hard problem of consciousness hasn't been solved and is so hard. We've been assuming that neurons, or embodied neurons, and he sort of gets broken off there, but that's okay. So there is a real independent world. Golf balls hitting people, apparently, pianos falling on people. To quote, I'm not a solipsist. I think there's a reality that exists independent of whether I perceive it or not. It's just not spatial or temporal. It's not physical. It's not space or time or physical objects. Something utterly different. Something utterly different. When I see an apple, I'm interacting with an objective reality. And that objective reality is utterly unlike an apple. It's something different, just like the icon on the desktop. So that's why the hard problem has been so hard. We've assumed that space, time exist, and neurons exist, even when they're not perceived. Something exists, but it's not anything in space-time. Even physicists of the first rank are saying space-time is doomed. Space-time is not fundamental. It's a data structure, evolution programmed into our species as a way of representing fitness payoffs for us. So finally, for a stopping point here, that's why all attempts to use physical systems like the brain or neurons or even AI systems, the whole framework of saying, could we take those diodes and resistors, voltages, and magnetic fields and put them together in a really complicated way? Could we create consciousness? And I think that whole way of conceptualizing the problem is fundamentally wrong. You're assuming that any object in space-time, like a diode or resistor, has causal powers. That's the problem. They don't even exist, except when they're perceived. So let's stop here. His solution approach is coming. We have to assess. Hoff's train of thought is very interesting. But he's already run way off the tracks. And later he's indeed going to fall into the gorge. Actually, already he's fallen into the gorge, but there's so many things it's hard to talk about them all. It's interesting because he has certain resonances to Bergson. Let's start with this. Neurons do not exist. No causal powers. Startling. But we've already seen this in Bergson. To quote from Matter and Memory, first page, chapter 1, paragraph 1, page 1. Here I am in the presence of images, perceived when my senses are open to them, unperceived when they are closed. And all these images act and react upon one another in all their elementary parts, according to constant laws I call the laws of nature. I perceive afferent nerves, which transmit a disturbance to the nervous centers, and then efferent nerves. I question the physiologists and psychologists. They answer that the centripetal movements give birth to the representation of the external world. What are we to think of this? The afferent nerves are images. To go on, the afferent nerves are images. The brain is an image. The disturbance traveling through the sensory nerves and propagating in the brain is an image also. If the image that I term cerebral disturbance really begot external images, it would contain them in one way or another, and the representation of the whole material world would be implied in this or that molecular movement. Now, to state this proposition is enough to show its absurdity. To make of the brain the condition on which the image of the whole depends, when the brain is just another image, is a contradiction in terms, since the brain is by hypothesis a part of this image, that is, the image of the whole. Another way to think of this, the brain is an image amongst all other images in the world. The brain is of the same order as all else. An image. It's part of this whole. It is not a privileged image. It cannot cause other images. So what is meant by an image in the universe is the aggregate of images. It's because we never see the actual thing, concept thing in itself. We see only an image, a part of, an aspect of a thing. The fly is an image. It's not the real fly, not the totality of the fly. And as we've seen, it changes with the scale of time. It could go to flapping its wings slowly like a heron, or an ensemble of electrons. The neuron is an image, not the totality of the neuron. All our knowledge is necessarily image, that is, aspects of a deeper, greater whole. But how to view this greater whole, this greater reality, the reality that per Hoff, that exists independent of whether I perceive it or not, be something utterly different. Bergson envisioned every object as such. Any given object acts upon all other objects in the field and is in turn acted upon by all other objects. It is in fact obliged to transmit the whole of what it receives, to oppose every action with an equal and contrary reaction, to be, in short, merely the road by which pass in every direction the modifications of what can be termed real actions propagated throughout the immensity of the entire universe. A little picture on the right showing this, the field of real actions, each object being the nexus, the intersection point of these real actions, or think waves propagating throughout the field. And again, one could take this at a completely different scale of time. same thing. But as such, it is unknowable, unimageable in its totality, in its full being as an object. We only experience the part that is an image thereof. The cup, an aspect that is a cutout, cut from this immense field of interactions, of real actions, of waves. The butterfly, an aspect cut from this field. This vision, this vast field of real actions propagating everywhere, we know led to his vision of this field as a holographic field. One image, the brain, does not need to develop and cannot develop a photograph that is an image of the external world. Why? As he said, but is it not obvious that the photograph, if photograph there be, is already taken, already developed in the very heart of things and at all points in space? That is, it's a holographic field. The photograph already developed at every point of space. That is, the information for the whole at every point. No metaphysics, no physics can escape this conclusion, as he said. Develop the universe with atoms. Each of them is subject to the action, variable in quantity and quality according to the distance exerted on it by all material atoms. Bring in Faraday's centers of force, the lines of force emitted in every direction from every center, bring to bear upon each the influence of the whole material world. Call up the Leibnizian monads, each is the mirror of the universe. And we know how he thus saw the brain, as a modulated reconstructive wave passing through this holographic field and specific to an aspect of the field. So a modulated reconstructive wave being the brain passing through the field. And again, modulating in the holographic framework, we're sending a reconstructive wave, say of a certain frequency 1, through the holographic plate, and the upward rising waves to the eye specify the virtual image, in this case of a cube, recorded with that original frequency of frequency 1. But we can modulate the reconstructive wave set to frequency 2, and then now we can reconstruct or specify the image, the virtual image of the cup. We can modulate the reference wave, the reconstructive wave, the frequency 3, and now reconstruct the object wave from the wine glass, again recorded with the frequency 3, or we can modulate back to frequency 1 and specify then the image of the cube. So again, the brain as a way of specifying or specific to an aspect of the field, and by this process now, an image that is a portion of the field, the coffee cup, the spoon. But what is the selection principle from this vast field of information? It's that related to the body's capability for action, information related to action. Perception is a display of possible action. For Bergson, perception is virtual action. The cutout from the set of real actions, now virtual action. Or, in Gibson's terminology, affordances. The coffee cup, affording, picking up, stirring, etc. You can call this fitness payoffs of the cup and the spoon, but we don't need natural selection. This will be my only comment about Hoff and natural selection. Namely, it's a ridiculously inadequate mechanism, natural selection, incapable of accounting for the complexity of these perceptual systems. We don't need it. Bergson didn't need it. We just need this understanding that the information selected from the universe, from the holographic field, is that relating to the body's capability for action. And this will also vary as a function of the scale of time. The brain with this energy state is imposing a scale of time on this field. The image is specified at a scale of time. And this as a function of the body's action capability. The buzzing fly at normal scale is a function of how I can act at this normal scale of time. It's hard to catch him. Raise the body's energy state. He now becomes a butterfly-like fly, slowly flapping his wings. This is also specifying how I can act at this scale. I can reach out slowly and grab it by the wingtip at this new scale of time. Or even worse, turn them into a cloud ensemble of electrons. Then we wonder what the Action capabilities are all about there. Virtual action. But consider the structure of one of these events, be it fly or coffee stirring. It's invariant structure. What's happening is the brain's modulation patterns are being driven by the invariant structure of these events. That's creating the different modulation patterns. This is basic structure at an ecological and physical level. So Hoff's, the fitness payoffs do not preserve the true structure of the world, unquote, is entirely dependent upon your take on true. For this structure, this invariant structure, is certainly a valid ecological structure at this ecological level and this scale of time. So this dynamically changing holographic field is the unknowable, unimageable reality. Hoff's something entirely different, kind of. But it is not that objects are not there or do not exist. As Bergson noted, that there exist planets, balls, butterflies, cups in this field. Certainly, it's just that they certainly do not have the precise outlines and forms we give them. They could become ensembles of electrons, and certainly they are time scale specific. They look different at different scales of time, and the Lord knows what they look like at the null scale of time, the most infinitely small scale of time imaginable. So is space-time dead? But space-time in Bergson's framework was always dead, in the sense that space-time is the classic metaphysic. The classic metaphysic where its space is an abstract space, simply a principle of infinite divisibility, a mesh we place under the concrete extensity of space, the concrete extensity. The meshes we shrink smaller and smaller to the continuum of mathematical points. And then we treat motion as a series of positions across this continuum, or through this continuum, where each position that the cup occupies, so to speak, for an instant is also corresponding to an instant of time. And this abstract time becomes simply the fourth dimension of this abstract space. Again, this is an infinite regress. As the fly moving there from A to B, we can divide each pair of points as another line of smaller points. Then between each pair of those points and that smaller line, yet a smaller line of points, etc. And that limit, we end with a mathematical point. It's indivisible because there is no start or end to a mathematical point. And so we end up with simultaneously then this notion that time consists then of a series of, shall we say, instantaneous cubes containing the all of space, the time extent of each being a mathematical point. And then each cube, therefore, at this utterly ridiculous scale of time, this mathematical point, becomes completely homogeneous, which is to say, there can be no qualities possible, nor is there ever more than one cube, then the next, then the next. No qualities, whether of color or motion or taste or anything else, are possible in this metaphysical space, which is the classic metaphysic, which is, of course, then where the hard problem comes from in terms of qualia. This is the classic or spatial metaphysic. Bergson replaced this. Abstract space replaced with concrete extensity, the concrete extension of the matter field, not a system of points. Abstract time replaced with duration, that is, motion, time is indivisible, not a series of discrete instants. For each instant in this indivisible motion is permeating the next, each reflecting the entire preceding series, like notes of a melody, that is, a melodic motion. The indivisibly transforming holographic field is a qualitative field due to this indivisible motion, not the homogeneous, qualityless cubes of space. This field then can support Hoff's trumpet sounds, his taste of chocolate. This is the temporal metaphysic of Bergson. This is the replacement. So again, are objects dead along with space-time? Besides the fact that objects have not the precise outlines we think, and are functions of the scale of time, in this indivisibly transforming holographic field, in reality there are not objects in motions. There is an elementary perceptual partition. This is an elementary perceptual partition, ultimately becoming conceptual in terms of the classic metaphysic for the sake of the body's action. And it leads to the classic metaphysic. Rather, Bergson argued, we must see the whole is changing. The whole field is changing like a kaleidoscope, where objects in motions are in reality changes or transferences of state within this dynamic, indivisible motion of the whole. Again, the temporal metaphysic. Hoff's problem, he has not escaped or even questioned the classic metaphysic. So this is Bergson's view of Hoff's hidden reality, of the real nature of space and time, that is, extensity and duration, and its objects, that is, of Hoff's, when I see an apple, I'm interacting with an objective reality, and that objective reality is utterly unlike an apple. It's something different. Well, this is the something different. And it's Bergson's view of the origin of our image of the external world, that is, of aspects of this unknowable, unimageable field, which is to say, of the origin of those icons, that is, of objects, coffee cups, butterflies, where the icons are equal to images, which are then in turn equal to symbols, symbols of greater realities, of which we see but an aspect, the specified image. So what is Hoff's solution to this problem? That is the origin of the image of the external world, which is equally to say of our experience, or to the origin of his icons, that is images, and the nature of the hidden reality we interact with. He has none. He has no solution. He is going to assume it, all of it. So let's watch. The interviewer, taking up where we left off. Your user interface. That's what you would call consciousness? Hoff. That's what I would call the physical world. I'm saying space-time and matter aren't the fundamental reality. So what is? What am I going to propose to replace space-time and matter? As a scientist, I'm going to propose a precise theory so I can find out precisely where I'm wrong. So I'm proposing that consciousness, or what I call conscious agents, is fundamental. Continuing. Instead of there being a space-time fundamental thing, there is really a vast social network of interacting conscious agents, an infinite social network of interacting conscious agents. Some of them are very simple. A conscious agent has a set of possible perceptions, conscious experiences, a set of possible actions, which are ways it affects the conscious perceptions, and then it has the ability to make free will decisions. There is no way he can ever define or fully delineate the set of possible perceptions or the set of possible actions. I put these pictures here just so you can see the absurdity of this. Get an idea. But here's a Markovian model thereof. So there's perceptions, free will decisions, and actions. I have a mathematical model just to give a hint as to how it can be precise. The set of perceptions is a measurable space. The set of actions is a measurable space. And the free will decisions are modeled by a Markovian kernel. And the actions themselves are modeled by a Markovian kernel. And the effects on other agents' perceptions are modeled by a Markovian kernel. So what's a Markovian kernel? It's a little matrix. And in this little Markovian kernel, this little matrix, there's two perceptions, red or green, and two actions, flip or make a face. If red, we have a 60% probability of a flip and a 40% for a face, for making a face. If green, we get a 20% for a flip or an 80% for a face. And it's a matrix whose rows sum to 1. That's the basic mathematics of this Markovian kernel and Hoff's approach. So the mathematics is very precise. There's nothing ambiguous about the definition of a conscious agent. And what we can do is have very simple agents that literally have one bit of perception, like red versus green, and one bit of action. So this penguin guy here is a 1-bit agent. He has a 1 or 0 red or green, a 1 or 0 flip or make a face. He notes then you can have a 2-bit agent. Combine these to make a 4-bit, and on, up to infinite possibilities for perceptions, actions, decisions. This leads to really big consciousnesses. So I can propose, for example, a definition of God. For the first time, God is an infinite conscious agent, where I've got a precise definition of conscious agent. So I can have precise theorems and proofs about God. For the first time, I am offering a mathematical theory about the letters God, G-O-D. Of course, I'm probably wrong, but now someone can say precisely where I am wrong, and we can now begin the scientific process of saying, I was wrong there, and how can we fix that? Okay, now look at a new God 2.0, and try that theory, and see where that is wrong, and see what it predicts. This seems, I guess, a little enticing, but Hoff is just proposing everyone get on his mathematical boat here. Henceforth, all arguments are going to be about how to steer his boat. Well, or maybe something else. But to continue the enthusiasm, so far, for the first time, we can begin to address those spiritual questions, death, meaning of life, purpose, with the rigor of the scientific method. Take death. Space and time is not the pre-existing state in which the drama of life plays out. Space-time is just my data structure. I'm the creator of space-time. What really exists is a vast, infinite social network of conscious agents, and space and time is just my interface. So death is just like a player in virtual beach volleyball. He takes off his apparatus, his avatar collapses on the beach. He's dead in the virtual world, but he's just stepped out of his interface. He's fine. The quote, once we realize that space-time is not the fundamental stage in which life plays out, it's not a fundamental reality, it's just a virtual reality that we create. Is it possible that when someone dies, all we see is the avatar that they leave behind? Now, it's certainly mysterious as to what happened to this. When I see an apple, I am interacting with an objective reality, and that objective reality is utterly unlike an apple. It's something different. But now objective reality is created by every conscious agent that comes along. I'm the creator of space-time. Remember the earlier equivocation, correlation versus causation, where Hoff claimed that only correlation with neural activity existed, but he really seemed to side with causation? Well, we're back. Causation, though now not even neural, is his thing. This fundamental ambiguity comes home. But now conscious agents are the creator, the cause. Of course, the agent is equally creating his experience. Actually here, experience equal objective reality, or selecting, is he selecting from his or her set of possible experiences? That is, or objective realities. Remember that set, actions, possible perceptions, which just apparently pre-exist. I don't understand, but not to worry. It's all mathematical. Yes, the ultimate reality here is conscious agents. This is idealism, as usual, without hope of accounting for the physical world. This is the classic impasse Bergson described in Idealism versus Realism. Idealism starts from consciousness as the only reality. Then it tries to derive the physical world. It thus struggles to account for the commonality and sharing of experience. Everyone's seen the piano hitting the guy, or everyone's seen, including the rat, the golf ball hitting the golfer. and the laws of nature, the order of science. There's order in physics and physical laws in both those events. But idealism, it cannot do so. Again, much shared experience. Everyone watching the Titanic go down. Realism starts from the physical world as the only reality. It then tries to derive consciousness. It cannot do so. Witness the hard problem. So one starts from consciousness as the only reality, one starts from the physical world as the only reality. Bergson showed how to break this impasse, how to go to an intermediate place between the two. He is barely considered worth studying by philosophy. Hoff certainly could have used him. Bergson noted summary and conclusions of matter and memory. There's two orders: that manifested in perception, contingent on the perceiver, and the order shown in science, independent, objective, deterministically bound together, lawful. Again, take the order in perception, contingent on a perceiver. The golfer makes a drive. Our observer, our perceiver, the rat says, nice. Then the rat turns the other direction and sees another golfer get hit on the head with a golf ball. Now, in between, there's a whole pile of intermediary events and physical laws taking place, determining the arch of the golf ball, wind, other things moving on the course, etc., etc. The order shown in science. Idealism cannot move between 1 and 2. Why? Because for idealism, perception/consciousness has a speculative role. By speculative here is meant pure knowledge. Its role is to obtain pure knowledge. It's not simply oriented to action. Thus, why would perception, the all-speculative medium, drop all the intermediate links between those two events in perception? John Stuart Mill, the intermediaries, or the intermediates, that suborder, are possible sensations. Kant, this substructure of order, the work of an impersonal understanding. For Hoff, it's consciousness that will account for everything, the entire substructure. But allow that perception is simply indicating possible action. That the brain is only indicating in the aggregate of things, the aggregate of images, possible action. I can then understand why the rest, all of the intermediate linkage, escapes me. And yet, all is of the same nature that I perceive. So all is of the same nature that I perceive. My consciousness of matter is no longer either subjective, as in English idealism, or relative, as in Kantian idealism. Not subjective because it is in things rather than in me. That is, my perception, my consciousness is in things. Again, with our little holographic model here, the specified image is right where it says it is, within the holographic field. This is direct perception, direct realism. It is the display of possible action, that is virtual action. There is no image in or being created by the brain. The entire field, the entire holographic field is perception. The question is simply how perception is limited. And the brain is a modulated reconstructive wave. Selecting only certain actions is the limiting principle. It's the selecting out of the apple from the entire field of perception at a particular scale of time. So perception is in things rather than in me. It's not relative because the relation between phenomenal, the phenomenal apple, the appearance of apple, and the thing, the actual apple, the apple in its true being, whatever level you want to consider it described, atomic or whatever, the relation is not of appearance to reality, but merely of part to the whole. Just for symmetry, a little closure. Realism's problem is sourced in the classic metaphysic. An abstract space and an abstract time. A space, when you look at its time extent, when it's taken to its limit, it's a mathematical point. It's thus utterly homogeneous. And a time, nothing but a discrete series of such instantaneous spaces. Thus, a space and time stripped of all quality, all possibility of quality, to include qualities of motions, rotating cubes, flapping winged butterflies. The brain is necessarily part of this homogeneous space. Thus, the origin of the qualitative image of the external world experience becomes a complete mystery. In effect, this is the source of idealism, for the former realist, like Hoff, ricochets from this unsolvable dilemma and ends in idealism, assuming consciousness, assuming experience. So you can look at it as a vicious cycle or circle. Hoff, so far as I can see, has not a worry about the nature of time or time scales, has never thought about the relation of subject and object, has not a question about the problem of memory. Is experience stored in the brain? That critical question. Has not a qualm about any hidden metaphysic he may be assuming. Has no explanation of the origin of the image of the external world, that is, of experience. He just postulates or posits sets of possible experiences. He is mistaken about the explanatory role and power of mathematics. He has no possibility of accounting for an objective physical world in his system. I think I'll take my Markovian choice. I've got to walk away from Hoff's vision. Mr. Rat is a bit depressed, but sorry, Mr. Rat, I'm sure Deepak will find lots of other theorists to consider. Down the road, temporal consciousness, still on the list. Susskind, physics, and the holographic principle, still interesting. QM's origin, black body, photoelectric effect in that, still interesting. And the great consciousness model neuroscience showdown that's being discussed nowadays, where certain theories are compared prediction-wise against each other. One, for example, being integrated theory of consciousness, which I critiqued heavily, global workspace theory, higher order thought theory, which I haven't dealt with because I haven't considered very powerful theories at all, but it could be an interesting subject. Susskind have already done, in fact, just haven't published it because the subject keeps deepening on me, but that could well be next. So what really will be next? We'll see. Till then, signing off.